preparation for exam 1, this video plans on going over 6 questions. One question is on compound interest, one on limits, one on continuity, one on rates of change, one on tangent lines, and one on the definition of the derivative. In 2022, you lent a friend $20. They invested it, and after 3 years, they pay you back half of the profit. Assuming that the interest is compounded yearly, if they return $30, what was the interest rate of their savings? The first thing we'll note is the keyword compounded. As soon as we see that, we know that we have to use compound interest, and so we can pull up the formula. Next, since this interest is compounded yearly, we know that m is equals to 1, and we can go ahead and simplify this expression. Now what we want to do is we want to go back over the question, and we want to try and figure out what the value for some of these variables could be. We know that in the beginning, they lent us $20, so their starting value for their investment was 20. Next, we know that it took them 3 years to pay us back, so t here is 3. Now this last part is a little tricky, because they don't pay us back the full amount, they only pay us back half of the profit, which means that if we got $30, their profit was 60 to begin with, and we also have to remember that there was the initial 20 that went into the account, and so our final amount is $80. Plugging this all in gives us an expression where we only have one variable, and that just so happens to be the one that we're trying to find. Now, it's just a matter of simplifying the equation. The first thing I want to do is I want to simplify the constants, so on both sides I'm just going to divide by 20. Now I want to get rid of that annoying exponent. To do that, all I'm going to do is take the cube root on both sides. Once that's all simplified, I'm left with 1 plus r on the right, and to just get r on its own, I'm just going to subtract 1 from both sides, giving us our final interest rate. Consider the following function. A. Find the limit of f of x as x goes to 0. Is f of x continuous at x equals 0? B. Find the limit of f of x as x goes to negative infinity. To find the limit at x equals 0, we want to know both the left-hand limit and the right-hand limit. We can begin with the left-hand limit. So as x approaches 0 from the left, we know that our function looks like this top part. And since our limit is to a constant 0, we can just go ahead and try plugging this in. As long as there's no 0 in the denominator, we should be okay. And the final answer gives us negative 2 over 3, so we're good to move on to the next part. Now, the right-hand limit looks like this other part of the function. We can try the same strategy by plugging in 0, and we see that we get 2 over 3. Now, even though the numbers look similar, because they're not the same, we can confidently say that the limit at this point does not exist. As for the second part of the question, we know that if the limit does not exist at a point, then the function is said to be discontinuous at that point. To find the limit as x goes to negative infinity, we know that we're dealing with the first part of the function, since that's the part that deals with all x that are less than 0. Since we're dealing with a limit to infinity, we want to try and get x in the reciprocal, so we're going to start by dividing by the highest power of x present in the denominator, which in this case is an x squared. We can go ahead and divide every term by x squared, and bringing the limit inside to each term gives us this expression. Now that we've done that, we can go ahead and resolve our limit, so everywhere where x is in the reciprocal, all these terms seem to go to 0, and so it simplifies to this expression, giving us a nice final answer of 0. For what value of k is the following function continuous? Well, for starters, we can note that f of x here is a piecewise function. It looks like it has two parts. The part on the left, where x is less than 1, looks like x cubed minus 3. But the part on the right looks to be a line. K as a constant here acts as a y-shift, so changing the value of k moves our line up and down. And for it to be continuous, We want to be able to draw this entire function without lifting our pen. In other words, we want these line segments to match up. To do this algebraically, we just want the left limit of the function to be equal to the right limit at this point, along with the value. Since the left limit at this point looks like x cubed minus 3, and the right limit looks like this line, we can just plug in these functions, and we know that at this point x just goes to 1, we can just plug in the constant to resolve the limit. Simplifying this expression allows us to solve for k, and we can see that that's exactly the value we got when we experimentally moved the line up and down. A light bulb manufacturer sells light bulbs for $4 each. At this price point, they can only contract 1,000 sales. Resident marketing genius Thomas Edison begins to offer discounted contracts where, for every zero point 0.5 drop in price, the number of light bulbs sold increases by 400. Now, this question has three parts. Part A. Find the formula for the revenue made from the light bulbs in terms of X price reductions, given that R of X is equal to the number of light bulbs sold multiplied by the price of each light bulb sold. Part B asks us to find the average rate of change from x equals 2 to x equals 3, and Part C asks us to find and interpret the instantaneous rate of change of revenue with respect to the number of price reductions when x is equal to 2. Before we begin solving any of the parts, let's go back to our question and try to understand the information provided. For starters, we know that light bulbs sell for $4 each, and at this price point, they give us 1,000 sales. We also know that for every $0.5 drop in price, the number of light bulbs sold increases by 400. Now for part A, the first thing we note is that our variable x is the price reduction in dollars. Next, we can go ahead and start putting what we know. So for starters, we know that when light bulbs are $4, we get 1,000 sales, so we can go ahead and just plug those numbers in. Next, we know that for every $0.5 decrease, in other words, for every 0.5x, we get 400 additional sales. Expanding these brackets out and simplifying gives us our revenue function here. Now part B asks us to find the average rate of change, so we can go ahead and pull up that formula. We know here that our function is going to be revenue, and the points that we're interested in are x equals 2 and x equals 3. Plugging that into our equation gives us these numbers, which we can throw into our calculator to simplify, and we end up with a final answer of 100. Part C asks us to find and interpret the instantaneous rate of change, so we can go ahead and pull out that formula. We know that the point that we're interested in is x equals 2. Plugging that all in gives us this big expression. Expanding all the brackets and simplifying gives us this, which allows us to cancel out our constants. Once we've done that, we know that every term in the numerator and denominator has an h, so we can go ahead and simplify this fraction by dividing an h from each term. And now that we've gotten rid of that pesky 0 in the denominator, we can go ahead and plug this limit in, and we get a final answer of 300. Now, since the question asks us to also interpret, we can think about what this value means. We know that the instantaneous rate of change refers to the slope of the tangent line at this point. We can think of it as the slope of our revenue function at x equals 2. And here it's telling us that increasing x will increase our revenue by around 300 at this point. Find the equation of the tangent line to the graph of f of x equals 3x squared minus 1 at x equals 4. In other words, if this is my function, the question is simply asking me to find the equation of this line, the line that crosses f of x at exactly this point, 447. Now we know that the gradient of the tangent line is given by the derivative, so we can go ahead and use this formula. Plugging our function into the formula gives us this expression. Our next step is going to be to expand these brackets so that we can go ahead and try and cancel out some terms. Sure enough, all of the terms without an h seem to cancel out, giving us an expression where every term in the numerator and denominator has an h. Now that we have this, we can go ahead and simplify this fraction by dividing an h from every term. Now that we've gotten rid of that pesky denominator, we can go ahead and plug in 0 and get a final answer of 6x. Of course, we want to find it at x equals 4, so we can just go ahead and plug in 4 into this equation, and once we multiply 6 into 4, we get that the gradient of the tangent line at this point is 24. But we're not done yet. The question asks us to find the entire equation, and so we need to plug this into a line equation. Now we already know what the gradient to the line is, all we need is a point. Luckily for us, we know what the point is, it was given to us in the question. So we can just plug in these numbers into our formula, and we can get a nice equation for the line. And purely for aesthetic purposes, we can even go ahead and simplify this further, just so we can get a nice gradient-intercept form. Looking back at our diagram, this now tells us that this red line's equation is y equals 24x minus 49. Let f of x be equal to 3x squared minus 4x. Use the definition of the derivative to show that f prime is equal to 6x minus 4. Show all of your work and use proper limit notation. However, I should let everyone know that for the purpose of the video, I may skip some algebraic steps. Since we're asked to use the definition, we can go ahead and write out what the formula for that looks like. Plugging in the given function gives us this expression, which we know that we have to simplify. So we can go ahead and expand out the brackets, giving us this big expression here, and we can go ahead and cancel all the like terms. Now that we have an expression where every term in the numerator and every term in the denominator has an h, we can go ahead and simplify this fraction by canceling one h out from each term. Simplifying this gives us an expression where we no longer have h in the denominator. Now we can apply our limit without having to worry about a 0 dividing. And plugging in h equals 0 gives us our final answer of 6x minus 4.